September 27, 1943. Richmond Shipyard No. 3, California. A complete Liberty ship, 441 feet of welded steel, 10,500 tons of cargo capacity, stood ready for launch after just 4 days, 15 hours, and 29 minutes of assembly. In every shipyard from Glasgow to Yokohama, vessels of this size had required 250 days minimum since the age of sail. Master shipwrights had spent entire careers perfecting techniques that the ship's builders had learned in 3 weeks. Quick pause before we continue if you love uncovering the real battles, secret tactics, and shocking reversals that shaped history. Make sure to subscribe and like this video. And tell me in the comments where you're watching from. I love seeing how these war stories reach history fans all over the world. Every week we bring you another untold story of courage, innovation, and survival. Alright, let's get back to the front lines. Over 2,000 workers stepped back from the hull of the SS Robert E. Peary. Not maritime craftsmen. Not naval engineers. Former grocery clerks, farmhands, schoolteachers, and housewives who 6 months earlier couldn't tell a bulkhead from a boiler. The crowd of admirals, engineers, and rival shipyard managers had gathered to witness what industrial experts had declared mathematically impossible just 18 months before. A revolution in manufacturing that would rewrite the mathematics of naval warfare. The Atlantic's destiny was being determined not by admirals or U-boat commanders, but by production speeds that violated every assumption about shipbuilding physics, labor requirements, and industrial limits. Yet the most remarkable element wasn't visible in the crowd of dignitaries or the army of workers. The catalyst for this impossible transformation stood nowhere near the shipyard that day. He was 4,000 miles away, behind barbed wire, in a German POW camp. The revolution had begun not in a planning office or university laboratory, but through a fence in Stalag 7A, when a captured American machinist, a former tractor factory foreman from Ohio named Robert Shaw, overheard German guards mocking American shipbuilding as pathetically slow. Shaw, covered in mud and malnutrition, didn't argue with his captors. Instead, he asked a question so absurd that even fellow prisoners thought the hunger had affected his mind. What if you built all the pieces at the same time in different places, then just welded them together like we did tractor frames back in Toledo? The German guards laughed. Traditional American shipbuilders would have dismissed it as the ravings of someone who understood factories, but not ships. What none of them grasped was that Shaw's outsider perspective, his complete ignorance of centuries of maritime tradition, would become his greatest contribution to the Allied war effort. Among those watching the Robert E. Peary launch was Admiral Howard Vickery, Vice Chairman of the United States Maritime Commission, whose agency had initially rejected Shaw's proposal when it reached Washington through Red Cross channels. Vickery had designed naval vessels for 2 decades. He had studied under the greatest maritime architects in history. The journey from prison camp whisper to industrial miracle began in the spring of 1942 when Shaw's letter, smuggled out through a repatriated medic, landed on the desk of industrialist Henry J. Kaiser. The mathematics of the Atlantic War were brutally simple, and by early 1942, they favored Germany. German U-boats were sinking Allied merchant vessels faster than British and American shipyards could replace them. Admiral Karl Donitz, commander of the Kriegsmarine submarine fleet, had calculated the exact formula for Allied defeat: sink 700,000 tons of shipping per month, and Britain would starve before America could intervene effectively. In November 1942 alone, U-boats sent 119 Allied ships to the ocean floor, 729,160 tons of cargo capacity erased in 30 days. Traditional shipbuilding couldn't keep pace with that rate of destruction. Even efficient British yards required 150 to 200 days to complete a cargo vessel. American yards, ramping up production after decades of peacetime stagnation, struggled to match even that speed. The Allies were locked in a race against industrial physics, and they were losing. But physics, it turned out, could be rewritten. What German naval planners failed to anticipate was that industrial velocity could function as a weapon more devastating than any torpedo. The faster American shipyards built vessels, the more impossible donuts mathematics became. Every day shaved from construction schedules represented not just efficiency gains, but strategic advantage. Ships reaching convoys faster, supplies arriving sooner, pressure mounting on German submarine crews who suddenly faced an enemy that multiplied faster than they could kill it. The transformation became visible in the production statistics that landed on Churchill's desk each month. In January 1942, American yards delivered 14 Liberty ships. By December 1942, they launched 91. By 1943, the monthly average exceeded 140 vessels. The U-boats were still hunting, still sinking ships with ruthless efficiency, but the math had inverted. For every merchant vessel sent to the bottom, 3 more slid down American launching ways. Kaiser's Richmond yards alone were producing complete Liberty ships in an average of 45 days by mid-1943. Other shipyards, forced to adopt similar techniques or face irrelevance, matched and sometimes exceeded that pace. The Todbath shipyards in Maine, initially skeptical of Kaiser's methods, cut their construction time to 38 days. Oregon Shipbuilding in Portland averaged 37 days. Bethlehem Fairfield in Baltimore hit 30 days consistently. The German High Command noticed. Intercepted communications revealed growing alarm about what Nazi intelligence called unmögliche Produktionsgeschwindigkeit, impossible production speed. U-boat commanders reported encountering convoys with more vessels than their targeting calculations predicted possible. German naval analysts, working with pre-war assumptions about American industrial capacity, kept revising their estimates upward and kept being proven wrong. Admiral Donitz requested more submarines. Hitler's armament minister, Albert Speer, couldn't deliver them fast enough. German U-boat production peaked at roughly 30 submarines per month, impressive by any traditional measure, but meaningless when American yards were launching 140 cargo ships in the same time frame. The strategic equation had shifted from can we sink them faster than they build to how do we sink 5 ships for every U-boat we have? The answer, increasingly, was that they couldn't. By late 1943, the Atlantic's mathematics had become a German nightmare. Allied shipping losses dropped from their 1942 peak while cargo capacity skyrocketed. The U-boat fleet, once the terror of the Atlantic, found itself hunted by increasingly sophisticated anti-submarine warfare techniques deployed from, ironically, American-built escort carriers that themselves rolled out of shipyards in under 6 months. Speed had become a strategic weapon more powerful than armor or armament. The Liberty ships themselves were mechanically simple, even crude by peacetime standards. They weren't fast vessels, barely 11 knots maximum. They weren't particularly seaworthy in heavy storms. Some broke apart in cold North Atlantic waters due to brittle steel welds. But none of that mattered against the central strategic reality. They appeared faster than Germany could destroy them. This was industrial warfare at its most fundamental. Not the clash of technologies or tactics, but the raw mathematics of production velocity overwhelming destruction capacity. Every 3 days, on average, another Liberty ship entered service. Every week, American cargo capacity increased by tonnage equivalent to what German submarines needed a month to sink. The British Ministry of War Transport, tracking convoy statistics through 1943, documented the shift with stark clarity. Atlantic crossings that had been near suicidal in 1942 became routine by mid-1943. Ships that would have represented catastrophic losses 18 months earlier were now acceptable risks because 5 more identical vessels were already under construction in American yards. Roosevelt's advisors grasped the strategic implications immediately. Speed wasn't just about shipbuilding efficiency, it was about compressing timelines across the entire war effort. Troops reached Britain faster. Tanks arrived in North Africa sooner. Supplies stockpiled for the inevitable invasion of France accumulated at rates that turned invasion planning from theoretical to concrete. The prisoner who sparked this transformation, Robert Shaw, still behind German wire in Bavaria, had understood something fundamental that escaped traditional naval architects. In modern warfare, adequate equipment delivered quickly defeats perfect equipment delivered slowly. His tractor assembly insight had weaponized velocity itself. By 1944, the Battle of the Atlantic was effectively over. German submarines still prowled the shipping lanes, still claimed victims, still fought with desperate courage, but they fought against mathematics that made their mission impossible. For every merchant vessel sunk, American yards launched replacements so fast that net Allied cargo capacity increased even under sustained U-boat attack. The weapon that won the Atlantic wasn't destroyers or depth charges or radar or code breaking, though all contributed. The decisive weapon was speed. Industrial velocity transformed into strategic dominance, built on techniques a capture machinist had sketched on smuggled paper 18 months earlier. Dönitz would later write in his memoirs that he knew the Atlantic War was lost when German intelligence reported American yards launching Liberty ships faster than his crews could be trained to hunt them. The U-boats hadn't been defeated by superior technology. They'd been defeated by something far more devastating, an enemy that could build faster than Germany could destroy. The woman operating crane number 7 at Richmond Shipyard number 3 had been a high school music teacher 6 months earlier. She'd never touched industrial machinery before January 1943. Now she guided 15-ton steel hull sections into position with precision measured in inches, working 50 feet above the construction floor, coordinating with welding teams through hand signals she'd learned in a 2-week training course. Her name was Dorothy Wright. She was 34 years old, from Fresno, California, and she represented the revolution's most radical element, proof that expertise was a construct, not a birthright. The Liberty ship miracle didn't emerge from elite engineering schools or generations of maritime craftsmen. It erupted from a workforce that traditional shipbuilding culture would have considered laughably unqualified. Women who had never held jobs outside their homes. Black workers barred from skilled trades by decades of union discrimination. Mexican-American laborers fresh from agricultural fields. Chinese-American welders who 6 months earlier had been grocery clerks in San Francisco's Chinatown. Young men rejected for military service due to minor disabilities who proved capable of precision work that masters claimed required years of apprenticeship. Kaiser's hiring policy was shockingly simple. If you could learn, you could work. Quick pause before we continue if you love uncovering the real battles, secret tactics, and shocking reversals that shaped history. Make sure to subscribe and like this video. And tell me in the comments where you're watching from. I love seeing how these war stories reach history fans all over the world. Every week we bring you another untold story of courage, innovation, and survival. All right, let's get back to the front lines. By mid-1943, women comprised 27% of West Coast shipyard workers, nearly 200,000 women in jobs that had been exclusively male domains since ships were hollowed logs. They operated cranes, read blueprints, managed logistics, welded pressure hulls, installed electrical systems, and supervised construction teams. Johnny Mae Craft, a 19-year-old black woman from Texas, became one of Richmond's fastest certified welders after 3 weeks of training. Her daily output exceeded that of journeymen with 5 years' experience. The numbers told a story that shattered every assumption about labor and skill. Traditional apprenticeships in shipbuilding required 4 to 7 years before a worker could be considered competent. Kaiser's training programs produced certified welders in 3 weeks, crane operators in 10 days, blueprint readers in 2 weeks. The quality of their work, measured in structural integrity tests, completion speed, and failure rates, matched or exceeded traditionally trained craftsmen. This wasn't just about filling positions during wartime labor shortages. It was proof that the entire concept of skilled labor had been artificially constrained by gatekeeping institutions that benefited from scarcity. the shipyards revealed an uncomfortable truth. Most expertise was learnable far faster than professional guilds wanted to admit. Richmond Shipyard No. 2 employed over 90,000 workers at peak production. Roughly 25% were women. Approximately 10% were black workers, in an industry that had systematically excluded African Americans from anything beyond menial labor for generations. Kaiser's yards paid equal wages for equal work, a policy so radical that several established shipyards refused to adopt it even under wartime pressure. The results spoke louder than the critics. In August 1943, a predominantly black crew at the California Shipbuilding Corporation in Los Angeles assembled and launched a complete Liberty ship in 10 days, a record that stood for months. The welding team leader was a 42-year-old woman named Willie Mae Thomas who had been a domestic worker in Alabama before migrating west for shipyard work. Her team's welds passed structural integrity inspections at rates exceeding 98%, better than industry averages from traditional, all-male crews. The social transformation rippled beyond the shipyards themselves. Entire new communities materialized around shipbuilding centers. Richmond's population exploded from 24,000 in 1940 to over 100,000 by 1943. Workers arrived from across the country. Dust Bowl refugees, Southern black families escaping Jim Crow, women fleeing limited rural opportunities. Kaiser built housing, established childcare centers near shipyard gates, created 24-hour cafeterias and medical clinics. The infrastructure of opportunity. Not everyone welcomed the changes. Traditional shipyard unions fought against the integration of women and minorities, arguing that standards would decline and safety would suffer. Some established yards maintained discriminatory practices, even as Kaiser's integrated workforce shattered production records. The evidence, however, was impossible to ignore. Diverse, rapidly trained teams were outperforming homogeneous, traditionally trained crews by every measurable metric. The skepticism wasn't just about prejudice. It reflected genuine disbelief that complex industrial skills could be democratized so quickly. Master shipwrights had spent careers developing expertise that teenagers now learned in weeks. The cognitive dissonance was profound. Either generations of craftsmen had been engaged in elaborate gatekeeping, or something fundamental had changed about how skills could be transferred and applied. The truth was both. Modular construction and simplified processes made training faster because the work itself had been redesigned for rapid learning. But the speed of skill acquisition also revealed that much of traditional apprenticeship length existed to maintain professional exclusivity rather than actual learning requirements. Maria Gonzalez, a 28-year-old mother of 3 from Texas, became a certified electrician at Portland's Oregon Shipbuilding in April 1943 after 5 weeks of training. She supervised installation of complex electrical systems on Liberty ships until 1945. After the war, when she applied for electrician positions in Portland, she was told she lacked proper credentials, despite having wired dozens of ocean-going vessels. The skills had been real. The opportunities evaporated once they were no longer desperately needed. That pattern repeated across industries and demographics after 1945. Women were pushed out of shipyards when men returned from military service. Black workers found skilled positions closed again. The extraordinary had been redefined as temporary exception rather than permanent possibility. But the proof remained indelible in the production records. In 1943 alone, America's shipyards, powered by workers that traditional industry had dismissed as unqualified, launched over 1,900 vessels totaling more than 19 million tons. That single year's output exceeded the entire British merchant fleet's pre-war capacity. The workers weren't extraordinarily talented. They were ordinarily talented people given extraordinary opportunity. Dorothy Wright returned to teaching music after the war. Her crane operator certification, earned through skill that moved millions of tons of steel with zero safety incidents, meant nothing in peacetime employment markets. But for 3 years, She had been part of an industrial miracle that proved a principle the establishment spent decades trying to obscure. Greatness doesn't come from pedigree. It comes from opportunity. The Liberty ship was, by traditional maritime standards, an ugly vessel. Naval architects trained in the elegant curves of clipper ships and the refined proportions of pre-war ocean liners looked at Liberty's ship blueprints with barely concealed disgust. The hull was boxy and graceless. The superstructure sat awkwardly amidships. The reciprocating steam engine, a design already considered obsolete in 1941, chugged along at a maximum speed of 11 knots, slower than many vessels built in 1900. The accommodations were Spartan. The finish work was crude. Welds showed where rivets would have been smoothed and painted on quality vessels. William Francis Gibbs, whose firm designed the Liberty ship based on British specifications, called it a dreadful-looking object. He wasn't wrong, but he was missing the point entirely. The Liberty ship wasn't designed to be beautiful. It was designed to be adequate, and to be adequate in massive numbers, delivered at impossible speed. That adequacy, it turned out, was more strategically valuable than perfection could ever be. Traditional shipbuilding operated under assumptions inherited from centuries of maritime craft. Ships should be built to last decades, should incorporate the finest materials available, should reflect the builder's reputation through quality of finish. A well-built vessel was a point of pride, a testament to skill, an object that would serve faithfully for 20 or 30 years. The Liberty ship design rejected all of that. Expected service life, 5 years, maybe less. Materials, adequate structural steel, nothing premium. Finish quality, functional, nothing aesthetic. The entire philosophy inverted traditional values. Don't build for longevity. Build for now. Don't perfect the details. Perfect the production speed. Admiral Emery Land, chairman of the Maritime Commission, initially resisted this philosophy. His training screamed against vessels designed for obsolescence. But the mathematics were undeniable. One perfect ship delivered in 250 days, or 8 adequate ships delivered in the same time frame. The war would be decided by tonnage and numbers, not craftsmanship and longevity. The design specifications reflected this brutal pragmatism. Liberty ships used standardized components wherever possible. Every bolt, valve, pipe fitting, and electrical junction was identical across all vessels. An engine part from a ship built in Richmond could replace a failed component on a ship built in Baltimore. Repair crews didn't need specialized knowledge of individual vessels. They needed knowledge of the Liberty ship, singular, because they were all essentially the same. This standardization drove traditional shipbuilders to distraction. Customization had been a hallmark of quality construction. Each vessel reflected specific requirements, particular conditions, individual builder preferences. The Liberty ship treated uniqueness as a bug, not a feature. Uniqueness slowed production. Uniqueness complicated repairs. Uniqueness was a luxury wartime couldn't afford. The welded construction, still controversial among traditionalists, exemplified the adequate over perfect philosophy. Welding was faster than riveting, required less skilled labor, and created fewer opportunities for leaks. But welds could fail catastrophically in cold water, particularly in early vessels before metallurgy improved. Several Liberty ships literally broke in half during North Atlantic crossings when brittle steel welds fractured. Traditional builders pointed to these failures as proof that proper riveted construction was superior. They were technically correct. Riveted ships were more resilient in extreme conditions. But riveted ships also required 250 days to build. The mathematical trade-off was stark. Lose 2 ships to weld failures but gain 10 ships through faster construction, or build perfect ships that arrived too late to matter. The Navy chose speed. By 1943, metallurgical improvements had largely solved the brittle fracture problem, but the underlying philosophy remained. Acceptable risk was preferable to perfect safety if perfect safety meant insufficient numbers. This calculation horrified traditional maritime culture, where crew safety was paramount and vessel integrity non-negotiable. But the crews themselves often understood the mathematics better than the admirals. Merchant mariners knew that the greatest danger wasn't weld failures, it was U-boats. And U-boats were being overwhelmed by sheer numbers of targets. The Liberty ship's mechanical simplicity further reflected adequate over perfect thinking. The reciprocating steam engine was ancient technology, inefficient and maintenance-intensive compared to modern steam turbines. But turbines required precision manufacturing and specialized expertise. Reciprocating engines could be built quickly by workers with basic mechanical training. Dozens of machine shops across America could produce engine components. Repairs could be performed by any mechanic who understood basic steam power. Speed of 11 knots. Adequate for convoy duty. Cargo capacity of 10,500 tons. Adequate for strategic needs. Range of 20,000 miles. Adequate for Atlantic and Pacific routes. Nothing exceptional. Everything sufficient. The contrast with German and Japanese shipbuilding philosophy was stark. Both nations emphasized quality over quantity, building fewer, superior vessels with longer construction times. German merchant ships were engineering marvels. Japanese cargo vessels incorporated sophisticated designs. Both were sunk at rates their industries couldn't replace, because perfect ships that don't exist can't carry cargo or replace losses. By war's end, American shipyards had produced 2,710 Liberty ships, more tonnage than the entire Japanese merchant fleet at its peak. Roughly 200 were lost to enemy action, accidents, or structural failures. That 7% loss rate, while tragic for crews involved, was strategically irrelevant when production replaced losses within weeks. The post-war fate of Liberty ships proved the adequacy of their design. Most were scrapped or mothballed by 1950, their service life over. A handful remained in commercial use into the 1960s. 2 still exist as museum ships. They weren't built to last, and they didn't. But they weren't built to become museums. They were built to win a war by 1945. And they did exactly that. The lesson extended far beyond shipbuilding. In warfare, in crisis, in any context where time matters more than permanence, adequate now defeats perfect later. The Liberty ship was never the best cargo vessel afloat. But it was good enough, and there were thousands of them, and they appeared faster than the enemy could comprehend. Perfect is the enemy of sufficient. And sufficient, delivered in overwhelming numbers, is often the enemy of defeat. The boardroom of Todd Shipyards in Brooklyn, February 1943. 7 men sat around a mahogany table that had witnessed shipping decisions since before the Civil War. The company had built vessels for the Union Navy, launched some of America's first steel-hulled warships, survived economic depressions and technological revolutions. Their reputation rested on 140 years of maritime excellence, craftsmanship passed down through generations, techniques refined by masters who had learned from masters. The production reports in front of them told a story they couldn't accept. They were being humiliated by a former dam builder who'd never seen a ship constructed before 1940. Kaiser's Richmond yards had just launched 30 Liberty ships in a single month. Todd's Brooklyn facility had completed 4. The mathematics were becoming impossible to ignore and more painful, impossible to explain to the Maritime Commission, which was now openly questioning why it should continue contracts with traditional yards when upstart West Coast operations were outproducing them 10-1. The collapse of traditional shipbuilding wasn't gradual. It was a cliff edge, and by 1943, the old establishments were tumbling over it. Bath Iron Works in Maine, founded in 1884, had built destroyers and cargo vessels through 2 world wars. Their craftsmen trained for years before touching critical construction. Their quality control was legendary. Their ships were maritime art. When Kaiser's methods began spreading in 1942, Bath's management dismissed them as wartime expedients that sacrificed quality for speed, temporary compromises that would be abandoned once proper shipbuilding resumed. By mid-1943, Bath Iron Works was implementing modular construction and welding techniques. Their construction times had dropped from 180 days to 45 days. The choice had been evolution or extinction. The transformation was profoundly painful for institutions built on craft tradition. Master shipwrights who had spent decades perfecting riveting techniques watched those skills become obsolete within months. Apprenticeship programs that had trained generations of maritime craftsmen were scrapped in favor of 3-week welding courses. Design philosophies emphasizing individual vessel customization gave way to radical standardization. The entire knowledge economy of traditional shipbuilding, the accumulated wisdom, the jealously guarded techniques, the reputation hierarchies, collapsed under the weight of a simple question. Why does this take 6 months when someone else can do it in 6 weeks? The old yards had no good answer. They had explanations: quality, tradition, proper methodology, crew safety, structural integrity, but Kaiser's ships worked. They floated. They crossed oceans. They survived torpedoes about as well as traditionally built vessels. And there were hundreds of them where traditional methods produced dozens. Bethlehem Steel, one of America's industrial giants, operated shipyards that had built vessels since 1905. Their Fore River facility in Massachusetts was a cathedral of maritime engineering, where skilled craftsmen had constructed battleships and ocean liners. When forced to adopt Liberty Ship contracts in 1942, Bethlehem's management insisted on maintaining proper standards, which meant riveting, extended construction times, and traditional craft hierarchies. By 1943, under pressure from the Maritime Commission, Bethlehem Fairfield in Baltimore had converted entirely to welded modular construction. Their average construction time, 30 days. Their craftsmen didn't appreciate the irony that abandoning their proper standards made them more productive than they'd ever been. The human cost of this collapse was considerable. Men who had built their identities around craft mastery found that expertise suddenly devalued. 60-year-old master shipwrights watched 20-year-old welders with 3 weeks of training perform tasks that had required years of apprenticeship in the old system. Union halls that had protected skilled trades through restrictive membership and lengthy training requirements saw those barriers swept away by wartime necessity and government pressure. Some resisted bitterly. Several East Coast yards maintained traditional construction methods well into 1943, even as their contracts dwindled and their workers left for West Coast opportunities. The New York Shipbuilding Corporation in Camden, New Jersey, once one of America's premier builders, clung to riveting and traditional layouts until the Maritime Commission explicitly threatened to cancel all future contracts. They converted in late 1943, slashing construction times from 200 days to 50 days within 6 months. The collapse wasn't limited to American yards. British shipbuilding, with traditions extending back to the age of Nelson, faced the same crisis. British yards had taught Americans maritime construction in the colonial era. Now American innovations were being imposed on British builders as requirements for continued operation. The reversal of industrial knowledge flow was perhaps more humiliating than the speed difference itself. Swan Hunter on the Tyne, John Brown on the Clyde, yards that had built the greatest ocean liners and warships of the early 20th century, adopted American modular techniques and simplified designs. British craftsmanship, legendary for precision and quality, gave way to American mass production philosophy. The ships that resulted were adequate rather than excellent, but adequacy delivered in volume trumped excellence delivered slowly. The Japanese and German responses were different, but equally desperate. Both nations, facing American production they couldn't match, doubled down on quality and sophistication. German merchant vessels incorporated advanced designs and superior materials. Japanese builders focused on specialized cargo ships with specific military applications. Both strategies failed because sophisticated designs required longer construction times, and longer construction times meant fewer vessels, and fewer vessels meant losing the tonnage war. By 1944, the question wasn't whether traditional shipbuilding would survive. It was whether anyone would remember it had existed. An entire industrial culture, centuries old, had been rendered obsolete in less than 3 years. The techniques, the hierarchies, the assumptions about what shipbuilding required, all of it swept away by methods a prisoner of war had sketched on smuggled paper. Some traditional builders never recovered. Yards that hesitated too long, that clung to old methods through 1943, found themselves without contracts in 1944. Post-war, when shipbuilding demand collapsed, these yards closed permanently. Their expertise, their traditions, their accumulated knowledge, all lost, not to enemy action but to industrial evolution they'd refused to acknowledge until too late. The irony wasn't lost on survivors. The shipbuilding industry hadn't been destroyed by war. It had been destroyed by innovation that won the war. And that innovation had come from a man who had never built a ship, inspired by a prisoner who had never seen one constructed. Tradition hadn't just been challenged. It had been obliterated. And what replaced it would define maritime construction for the next 50 years.